All right, welcome to the coding part of this video. This one's actually really, really simple. So if you've been kind of struggling with Python, just know that this one's actually a lot easier than most of them. So I'm going to just quickly go through some of these options. First, we're going to bring in the packages that we need, like usual, and we're going to use our BBC News data set again. I did note here, some of you are using printdf or printdf.head. All you have to do is just df.head with the parentheses and it looks a lot better. You'll see if I add print here, it's kind of ugly. So go ahead and take that out and that will work a lot better for you. Then the size of the data set. So we're going to go through just quickly some of the data prep. In this one, I made my stop words list. I customized it a little bit. And then I added some notes about data cleansing. So just read through it if you want. I had like a cleaning the house analogy. But basically, if you think about cleaning your house, you are not going to vacuum first and then start dusting your ceiling fans because you know the ceiling fans are going to have dust on them. That's just going to fall and you're going to get dust all over your brand new vacuum floors. Same thing with text. We don't want to clean one thing. So for example, we wouldn't want to do a lematizer and then try to take out stop words, which I actually, now that I say that, I think I do have this in this, whoops. Stop words honestly probably wouldn't be a big deal, but if I like did one change and then I try to take something out, it might actually be messing things up later. Anyway, I don't know if the analogy even works, but in general, just keep track of how you're cleaning your data and think about how it might impact things down the road. Let's see. Okay, so lemmatization. We've done this before, but I added in a new one from spaCy. Some instructions here. I did update some of the instructions because the one that was here was a little outdated. And then this one's a really good link to figure out how do I actually import things. So there's some pip installs you'll do. I have these commented out, so just make sure to uncomment them. You can either delete the pound sign or let me put that back. Or you can highlight things and press, let's see, that one. Oh, I always forget the keyboard shortcut. Nope. Oh, it's that one. Okay, so on Mac, it's Command and then the question mark. So on Windows, it'd be Control and the question mark. So that's how you do that at bulk. So import spaCy. We load in our parser, and then sorry, I've been getting over the summer cold that's been going around. And then you can just run this where it applies it, and then it'll add it there. So just another method. Now you know a ton of ways to do the lematizer. So same as usual, lematize, stemming, whatever you want to do. We're going to do a vectorizer. And then I added some extra cleaning things here. So I noticed there were a ton of numbers in here. So I decided to take those out. And thankfully ChatGPT is very nice for that. I even put in my prompt here, which I would love if you would tell me the prompt you use to get any code. I like telling people the prompts I use so that we can better just get good code from it. So I said, create a function in Python that removes all digits and non-English characters from a pandas column. I specify pandas because a lot of times it'll do it for like one value, and we're never just doing things for one value. We're using a data frame. So it defined this and it helped me kind of figure that out. Sorry, you do not want to get the summer cold. It's not fun. But all that is to say, here's my clean column, and now it doesn't have punctuation, it doesn't have numbers. It tried its best at non-English characters. I will tell you that's one of the hardest things in text mining is when there's accent marks and different encoding things. It's kind of a nightmare. Custom replacements. So these are some from a previous data set I just kept in there so you could see. But one I did do in this one is I changed Ukrainian president to Zelensky. So that way, whether they say Zelensky or Ukrainian president, both will come up as Zelensky, and we can get a better count of how many times he is specifically mentioned. So I define that. It's just word, a colon, and then the replacement. And then here's the function. I got this a long time ago. I don't even remember who from. And then I just replace it like this. And then this is just a nice little preview code. You could also just df head 1. So now instead of the Ukrainian president says the country will not forgive or forget those who murder its civilians, it now says the Zelensky say the country will not forgive or forget those who murder its civilian. We still understand what it meant, but now Ukrainian president is Zelensky. Again, that helps us if we're trying to understand, are they mentioning Ukrainian something else? Are they mentioning a different president? Now we know it's just always, if it's Ukrainian president, it's always going to be Zelensky. It took away the plurals. It kind of standardized everything. It still hasn't taken out those stop words. It's going to do that last, but you see that it's a lot cleaner. So did all that. I'm going to do my TF IDF again. And you see it looks a little bit better. I can print the top words by weight. But now we're getting to the actual sentiment analysis. So there are a few different methods for this. I'm showing you, I think, 3 or 4. You can use any of them that you want. I do recommend you compare and contrast the results though, because some of them are going to be more accurate. Some of them are going to be better for certain data sets, and it's not always just cut and dry. So I'd say just try them. This first one is Vader. It is from NLTK. So all you have to do is import it, initialize it, and then you can run your scores through it. And this one, it's talking about the scores, and it gives you a negative, neutral, positive, and then compound score. The compound is the one that we want. So I then run this little code to say, hey, get me the compound score. And if it's greater than 0.05, it's positive. If it's less than negative 0.05, it's negative, and anything else, it's neutral. And then I implement that. And you can see now I have my little sentiment score. And then this piece of code tells me how many negative, positive, and neutral documents are in my corpus. So if you look at this, you can quickly see that most of the headlines, by just a slim majority, are negative, followed by positive, and then neutral. If you're thinking about news data sets, I would almost assume that most are going to be negative or neutral. I don't know how many positive, I don't see a lot of positive news. But depending on your news set, there might be more positive. Maybe there's more sections in sports, or they're phrasing things a certain way, or it's financial and like things are on the up and up. We're going to see more positive. So this is something where we can measure over time, and we can see when our news cycle is kind of more positive or negative, especially as we start to get into an election year. We could also see just in general, how do we compare Vader versus another method? Does one tend to be more negative? So the other method is Afin. So I have files out there on Brightspace you have to put in your Python folder first, because we're actually opening it right here. And again, I give you all the code. I don't think you have to change nearly anything about this except what your columns are called if you want to. But this is opening the Afin dictionary. It's defining what's positive, negative, and neutral. And then we just apply it like this. So now you can see I have my Vader and my Afin. Both actually say it's negative. Oh, this one actually came up with results, the one I just said. So more negative, neutral, and then finally a small bit of positive. HL is going to be the same thing. It does have a positive and a negative file, so you'll have to have both. Again, you don't have to change anything about this. Just make sure these files are in your Python folder. apply it and we can see. And again, this particular one is doing a lot of negative ones and it's doing it correctly, I would say. Um, but then we can get our value counts and we can also start to compare. So I look, okay, all of these, most of these are negative. I do see this one where one said it was positive and two said it was neutral. And if I read this, consumers are feeling the impact of higher energy costs as fuel prices and household bills jump. Now we read that and probably say, hey, that's negative, prices are going up, people are suffering. But if you look at the specific words that are used, it's not particularly negative. And that's where we would need to add in additional context. Maybe we say a phrase like higher costs, although there is energy in there, so that'd be hard to kind of parse out. Um, we would know that that's negative. The word jump in here is maybe not as commonly used in this context. So it was probably negative, but or neutral, I mean, but we might say like if bills are doing anything, they're probably going up and it's negative. So just kind of keep that in mind. We can play around with it and start to add in some additional things. It's always going to get something wrong, so don't be too discouraged if some of these are just they're not going to be what you want. And because we have things like sarcasm and our specific phrasings, we know things are bad, but the words we're using are actually positive. So just kind of a weird thing with our language. And then this is a nice way to see the value counts for each of those. The pivot table doesn't print out as nicely. Honestly, you might want to just open it in Excel, but you can start to see if AFIN, Vader, and HL are saying things are negative, positive, or neutral, and start to compare those. So in this code walkthrough, we looked at dictionaries and we looked at implementing 3 different sentiment analysis dictionaries. And we saw how to compare and contrast those. In your homework, you're going to be doing exactly this. And part of what you're going to do is actually go through some of these results and say, why is it correct or incorrect? And kind of give your feedback on it. So I use this one as one of my first examples. And if you look at this, you understand that murder is a very negative word. No matter what the rest of the sentence says, it's probably going to be pretty negative. And I specifically called out forgive and forget might be positive, maybe neutral, but the fact that murder is, again, such a negative word, it's probably bringing the score down to a point where there's no way it's going to be a positive statement. There's going to be some that use really, really positive words, and maybe it's sarcasm, or maybe it's like the bill one. It's really negative, but we're using positive words. So just kind of call out where it works and where it doesn't and why. And that is it for the Python version. Have a great week.